Alright, so in this slide, we're going to look at latent heat. Now, previously, we know that, okay, when a system gains heat or receive heat, alright, the molecules or atoms in the molecules, okay, will increase its internal energy, okay, and thus the temperature of the system will increase, right? In some situations, right, when we added heat, okay, to a system, right, the system will not have an increase in temperature, right? Meaning the temperature remain as it is, right? So here, the heat added, okay, is not to increase the temperature, but to change the phase of the system, all right? So whenever heat is added, okay, whenever heat added, okay, and it contribute to the change of phase of the substance, okay, change phase of the substance, right? So the energy here is known as the energy required here, or the energy that we call here is known as latent heat. Alright, so latent heat is one type of energy that being transferred not to increase the temperature of the substance, okay, but to change the bonding of the molecules inside the system. Alright, now as for example, okay, example, let's say we have a certain mass, okay, of ice, okay, of ice initially at negative 30 degrees Celsius, okay, as indicated in the figure here. Alright, so actually this is graph T versus Q, okay, T versus Q. Alright, as you can see here, alright, initially the ice is at negative 30 degree Celsius. Alright, so when certain amount of heat is added to it, okay, here we have 62.7. Alright, so I name this one as Q1. Alright, Q1 equals to 62.7 joule. When this amount of heat is added to the ice at negative 30 degrees Celsius, what happens? Alright, there will be a change in temperature. Alright, the temperature of the ice increase from negative 30 up to 0 degree Celsius. Alright, so as indicated by A dekat sini. Alright. Okay, and then what happened after it reached 0 degrees Celsius? Now we know that 0 degrees Celsius is the freezing point, isn't it? Okay, it's the freezing point of water. Alright, so what happened at 0 degrees Celsius? Once the ice is fully melted, okay, what happened is that, okay, not fully melted, begin to melt, okay, as the ice begin to melt, all right, when we continuously add heat here, okay, continuously add heat, what happened? Okay, the here at B, all right, the energy is not to increase the temperature, but to break the bonding of the atoms of ice, all right, to become water. Okay, to become water. Alright. So what is the amount of energy required to break the molecular bonding here? It will be 396, okay, minus 62.7. Okay, that is equivalent to 333 joule. Alright. So this amount of heat is required to break the molecular bonding. Alright. So basically, untuk yang Q1 tadi ni, okay, to increase the temperature from negative 30 to 0 degrees Celsius, okay, Q1 equals to MC delta T. Alright, delta T, where T delta T adalah T final minus T initial. Okay, T final is 0, T initial is negative 30 degree Celsius. Alright, so this is the amount of energy required to increase the temperature. Alright, untuk Q2, alright, at point B here, ini point A, at point B, alright, you can see that the amount of energy required to break the molecular bonding is 333 joule, alright. So this is equals to ml, alright. So the energy that involve latent heat is given by ml, alright, where L is, okay, if you still remember, okay, L adalah latent heat of fusion. It has two types, okay, latent heat of fusion, and the other one is latent heat of vaporization. Alright, so latent heat of fusion is when solid change to liquid, okay, change phase to liquid. For vaporization, okay, when liquid change to steam ataupun gas. Alright, we have two types of latent heat. Right, so this is L, refer to latent heat of fusion, LF. Alright, now since here the phase change from solid to liquid, alright, so ini adalah positive ml. Okay, kalau sebaliknya from liquid to solid, it will be negative ml. Alright, so please take note. Now, at C. Now, once the ice completely melt, okay, completely melt, right, what happened? As we add more energy here, okay, more energy, as you can see at Q3, okay, Q3 is 815, okay, 815 minus 396, minus 396, alright, so this will give us 419 joule of heat, alright. So this amount of energy, 419 joule, okay, is required to increase the temperature of water from 0 to 100 degree Celsius. Alright. We know that 100 degree Celsius is the boiling point of water, isn't it? Boiling point of water. Alright. And this is equal to MC, C water. Alright. T final tolak T initial. 100 minus 0. Alright. Ini untuk C. Alright, so when the water begin to vaporize, okay, so meaning that here, when energy is added, as you can see, okay, dekat point E ni berapa? Point E ni adalah 3070, alright. So the amount of energy 3070 minus 815, alright. So this will give us 2.26 times 10 to the power of 3 joule. Alright, so this amount of heat is required to break the molecular bondings of water to become steam. Alright, so this one equals to ml, and this is LV, latent heat of vaporization. Alright, now continuous amount of heat. Okay, continuous amount of heat, as you can see here dekat sini. Alright, so here we have 3110 minus, okay, 3070, alright, ataupun approximately 40.2 joule. Alright, so when we have more energy added to the system, alright, the water completely will completely become steam, alright, become gas, alright. So as you can see here dekat sini, alright, so dekat sini semua dah jadi steam or gas, alright. So dekat sini kita ada right, okay, so meaning that dia jadi steam, let's say sampai 120 darjah Celsius, alright. So ini M, yang ni C steam, alright, C steam, and then we have 120 minus 100, alright. So the total energy required, alright, to convert, okay, to convert negative 30 kilogram of ice to become a steam at 120 degrees Celsius. Alright, so the total energy would be the sum of, okay, Q1, okay, plus Q2 plus Q3 plus Q4 plus Q5. Alright, so this is the amount of energy required for the whole process, okay, from ice until to become a steam. Alright, okay, so this is the formula used. Alright, from here, okay, Q equals to plus minus ml. Okay, as I have mentioned before, okay, plus kalau from solid to liquid, liquid to steam, minus kalau steam to liquid and liquid to solid. Alright. Okay. So table 19.2 lists latent heats of fusion and vaporization, okay, for certain substances. Alright. So biasanya in this topic, okay, kita cuma tengok water lah. Okay, we stress more on water. Alright. So next slide kita akan tengok more examples.